This is problem number 1 on the sample test problems for test number 2. The population started at 10,000 people, and after 20 years it had doubled. Express the population as a linear function of the number of years since the population was 10,000. So what I'll do here is define x to be the number of years since the population was 10,000, and y is going to be the population at year x. And so I think what we're saying here is that if we want some xy ordered pairs, then the first point we're going to have is going to say, all right, the population was 10,000. And the way we've defined it, that's what we're calling year 0, since x is the number of years since the population was 10,000. Now we need one more ordered pair in order to find the equation of a line. It says after 20 years, so that's x, the population had doubled. So it must have gone from 10,000 to 20,000. So now what we need to do is find the equation of the line that connects those 2 points. So first thing I want is the slope. So that's a change in y over change in x. 20,000 minus 10,000 divided by the change in x, 20 minus 0. Just make sure you subtract those points in the same order on the top as you did on the bottom. Upstairs we get 10,000. Downstairs just 20. And I think that's 500. And then the other thing that we need, we're going to do this y equals mx plus b. It's going to be the y-intercept. And I think we're given a gift in this problem because the y-intercept is right there. B is 10,000 because it happens that that's when we have x equal to 0. So I think we're good. Just copy this. M was 500, that was the slope. X plus, and then the y-intercept was given to us as 10,000. So that's the equation of the line. And then in part B, when will the population be 40,000, assuming this linear growth? So what we're going to do is we're going to replace the y value with 40,000 because the y value is the population. So this equation comes over here, and we get 40,000 equals 500x plus 10,000. And now we need to solve for x, so subtract 10,000 from both sides. And divide by 500. And I think we get x equals 60. So in 60 years, we'll get up to 40,000. And just to point out that the doubling time going from 10,000 to 20,000 was given as 20 years. So the first doubling took 20 years, but then if I wanted to double from 20 to 40, which is what we were given in this problem, it didn't take another 20 years, it took much longer, it took 60 years.